In 44 through 55, indicate which of the functions in the referenced exercises are one-to-one correspondences. For each function that is a one-to-one correspondence, find the inverse function. So 49 is exercise 12b, and here I have exercise 12b. Define capital G from R to R by the rule g of x equals 2 minus 3x for each real number x. Is G onto, prove, or give a counterexample. Now, we don't have to worry about the onto or counterexample or anything. That's not the purpose of number 49. The purpose of 49 is to ask ourselves, is capital G one-to-one? And if it is, can we find an inverse function? The graph of this function would look like the equation of a line that you learned from algebra. It has a y-intercept of 2 and a slope of -3. So really, if we want to think about what's being asked here, we can consider the question, does this graph pass the horizontal line test? Remember that the horizontal line test that you learn in pre-calculus is the same test that we use algebraically in the discrete math class. So if visually this graph satisfies the horizontal line test, then algebraically it would also satisfy the definition of one-to-one. Now, this function definitely passes the horizontal line test because there are no horizontal lines that we can draw that passes through multiple points. Every horizontal line that we draw on this graph crosses the function exactly once, actually, which means that the function is onto and one-to-one, so it's technically a bijection, which means that it's injective and surjective, or one-to-one and onto. But that's beside the point. The point is it passes the horizontal line test. So yes, it's one-to-one. We don't need to justify this with a proof. We can just ask ourselves whether or not this is one-to-one by graphing it and seeing if it passes the horizontal line test. Now that we know that this function is one-to-one, let's find the inverse function. The way I do this is I like to represent the output variable as something like a y. So y equals 2 minus 3x. Now, teachers teach to swap the x and the y, but I think this is actually a really detrimental way of thinking about it because x corresponds to the domain of capital G and y corresponds to the codomain of capital G. And to swap those can be really confusing. Why would we swap them? Instead, what we're going to do is we're going to rewrite this formula so that it's x equals instead of y equals. And to do that, we essentially need to undo all of these operations on the right-hand side. Now, according to PEMDAS, you're supposed to do multiplication before subtraction, but when you're solving for x, you have to undo the operations in reverse order. So to solve for x here, I'm going to subtract 2 on both sides, and then we'll divide by 3. So we get x equals y minus 2 over 3. Now, I haven't swapped the letters. This x really does represent the same x as the original function here. This x that you're looking at is the same x here. This y represents the same y as the outputs of this function. So the outputs are now playing the role of the inputs. If you want to find x here, you have to plug in y. So if you want to find the inputs of this function, you have to plug in the outputs. That's precisely what the inverse function is all about. What this really means is that the inverse function, keep in mind that's not an exponent there, g inverse of y, I'm not going to use the same letter x because I think that's kind of misleading here, is equal to y minus 2 over 3. So this function unpacks all of the operations that capital G does to the input variable in reverse order. So it essentially undoes capital G. Thanks everyone, and I'll see you in the next video.